Hey everybody, how's it going? This is Sean here, and today I'm doing a course project, and this course project is called Harnessing the Power of Large Language Models with Langchain, an introduction to ReAct, Reason in Action, and RAG, Retrieval Augmented Generation. Now, this is the introduction to Langchain using these paradigms, and I'm going to go over these in detail through this course project. But if you aren't academically involved in this and you're seeing this on my channel, then you'll get a really in-depth overview of how Langchain library works, what to expect from it, and how these different paradigms are constructed to be used. So let's go ahead and get started. So we're going to go over the introduction, which we'll go over some of the core concepts. I'll explain these to you, and then we're going to actually dive into the Langchain library. Then once we dive into the Langchain library, we're going to go into the ReAct paradigm. We're going to look at the ReAct paper and discuss some of its premonitions. And then we're going to discuss RAG, Retrieval Augmented Generation. And after we discuss these, we will do a demo using these technologies in a notebook, which I'll have openly and publicly available for anybody to use. You will have to get your own keys though, and we will use different tools, and we will see how an agent works using ReAct and using Retrieval Augmented Generation on real data. We're going to use a Star Wars data set that I developed that does Star Wars question and answering. It's pretty fun. So, and then after that, I have a couple other tools that I'm going to mention that I think are very paramount for anybody in the NLP space or in deep learning industry who needs to know about this type of stuff further day to day, because as a senior AI engineer, I can tell you firsthand that every day I'm doing research and working and writing code and doing lots of other things, and it's paramount to stay on top of all these changing technologies because they go really fast, and things are growing and blowing up very quickly. So let's go ahead and let's get into it. So for our introduction, we are first going to jump into natural language processing, which everybody in my class knows. Natural language processing is the branch of artificial intelligence that focuses on enabling machines to understand, interpret, and generate human language. It combines computational linguistics, role-based modeling, human language with statistical, machine learning, and deep learning models. These technologies enable computers to process human language in the form of text or voice data and actually understand it in its full meaning, complete with the speaker's or writer's intent and sentiment, which is a really big thing. And it's really exciting now that we have large language models. And NLP is significant because it helps bridge the gap between human communication and computer understanding, leading to numerous applications such as chatbots, translation services, and personal digital assistants. Now, large language models, as you may know, like Llama 2 or OpenAI's ChatGPT 3 and 4, or their new 4 Turbo that they just released about a week ago, represent the cutting edge of NLP right now. These models have gained a reputation for their remarkable ability to generate coherent and contextual, relevant text-based information on a given prompt. Achievements in LLM have been groundbreaking in various generative tasks, as they could produce creative writing, emulate human-like conversations, summarize information to translate different languages. They can even generate software code and many other things, which is one of my favorite parts about LLMs. And the importance of LLMs lies in the versatility and their profound impacts on large language understanding in their applications by leveraging massive data sets. It's for the first time in human history. We've had a lot of these algorithms around since the 50s, but we just never had the computational power until now to actually take all this data and infer it and run our computational models on it, and run them with sophisticated neural network architectures. Now, LLMs have become an integral to advancing NLP and its applications. So some recent advancements. Now, before we dive into the Langchain library, I want to discuss and outline some of the transformative paradigms that are reshaping the way we harness these AI-driven language LLMs. And that is using the ReAct and the RAG methodologies, which are representative of the innovative strides currently being made in the realm of NLP, especially in tools like Langchain. They not only enhance the capability of LLMs by the way of insertion of external databases, different documents, text files, PDFs, images, you name it, but also structure the decision-making process, thus providing a more nuanced and informed interaction with our large language models. Basically, we're allowing them to take actions on their own reasoning, giving them, a loop to think off of, basically, instead of just outputting certain information that it retrieves based off a similarity search. So we're going to look at these paradigms and how they serve instrumental for the bedrock for tools like Langchain to build upon, and why understanding them is crucial for us to fully leverage the potential of machine learning in natural language processing. We are going to go over the ReAct paper, which provides a detailed model and shows how we can organize and process steps of reasoning and actions when interacting with these LLMs. It provides a framework for developing more sophisticated applications and requires a nuanced understanding of processing information. Then we're going to touch base on the concept of Retrieval Augmented Generation, which refers where the LLM's outputs are actually enriched with information dynamically retrieved from data sets or their knowledge base. These can be your files, your documents, databases, API information that it brings back. And RAG allows LLMs to generate responses that are not just based on pre-existing knowledge encapsulated during training or fine-tuning, but also on the latest, most relevant data, driving the next level performance in question and answering dialogue and conversational system. It's pretty amazing, and we'll see a demo of that here pretty soon. So now we're going to go over discussing the Langchain library. And as opposed to going through the slides, which I do have put together and just showing you still framed photos of Langchain, I thought we'd just go ahead and take a different route. We'll just go ahead and jump over on the website and take a look at it. So this is Langchain.com. If you go through, they've got their own proprietary products, and as you can see here, they've partnered with some of the biggest names in tech. Langchain is a versatile framework designed specifically for building applications that leverage the capability of large language models. If you are a programmer, and you might be familiar with frameworks like Flask or Axios or different types of library packages that that help you do certain functionalities like APIs. I like to call this like the Axios of large language models, because this whole library is built to give us and leverage large language models like we've never been able to use before, given the conceptuality of how new a lot of this technology is. And it targets the creation of structured interactions which assist in constructing applications that utilize LLMs, APIs, and many other things in a way that is efficient, optimized for various tasks. Langchain focuses on enabling applications that are context aware, such as connecting large language models with different sources, different prompt structures, few-shot examples, using different types of algorithms and machine learning paradigms and context to help ground the model's responses. Furthermore, it includes tools for workflows where language models are used for reasoning, such as determining how to answer questions based off given context or deciding what actions need to be taken. Now, some of the problems and challenges in Langchain, based off of what they solve, is several challenges that developers face when trying to integrate with LLMs into production environments. And one such challenge is difficulty of creating applications that remain scalable and maintainable while achieving performance expected of large language model based type applications. Additionally, it tackles the problem of handling out of context information by making applications context aware and managing complex language applications. Langchain is very verbose and very robust. And as you can see here, it's got a complete set of powerful building blocks, which are the Langchain components, which we'll go into more detail here later. And we'll kind of do a brief walkthrough. I won't go through the entire library, but as you can see, they handle a lot of different things here, that can be used to leverage large language models for any type of use case, pretty much, that will require using an LLM. Now, these tools context of, agents, tools, models, selectors, prompts, vector stores, document loaders, output parsers for the type of data you get back from the LLMs. One of the big ones that Langchain has solved is developing what's called agents. That's where you turn your LLMs into reasoning machines, and these are basically high-level structures that choose which types of tools or sources to base their objectives defined by the user. So a tool could be something that can tell this model to go online and pull some information off, or to get the weather, or to do a math problem, or to look at your types of documents and bring back some results in a cohesive way. Agents can execute complex strategies involving multiple large language models, which I'll show you in our demo, and different data sources, providing an adaptive layer that respond to varying contexts and objectives. Now, in all, the core concept of Langchain, which if you actually type this into another most recent model like 3.5 GPT, it tells you that Langchain was actually a blockchain project, and it was until recently. And Langchain offers chains which refer to sequence of calls to these language models or other processes that allow for the elaboration or task, and they are pretty much the backbone of the framework's operation and can be seen as workflows, basically, that pass information from one step to the next, cumulatively building towards the end goal of what we want to achieve around our large language models. Then we have tools, which these are adaptive confines that the agents use, and they've got a bunch of integrated ones, and this list grows every day, and we can actually build tools customizable too. And I've actually got a tool that I built that's custom for our use case in our demo over here. But you can do anything on these. You can go to PubMed, you can search APIs, you can search Google, and the cool thing about these agents is we can use different algorithmic models like ReAct, and we can have a system in place that'll take your prompt, it'll look your prompt up, and it'll ask itself questions to keep determining whether it's returning the right answer or not. And then based off that, it chooses which tool to leverage to pull information from to construct that answer, which is really cool. And it really puts large language models, it just boosts them like over the edge and what types of things we can do with them. But we will go over that here in just a second. Other integrations that Langchain has is basically, and I like to refer to this little thing here, is it facilitates integrating with a variety of third-party providers and different platforms, which we've kind of looked at down here. It ensures that users can leverage the best tools and services available, and these integrations may include cloud services, API providers, specialized databases. One that I currently highly recommend is PG Vector. Very fast, very efficient, and its Postgres vector database is very, very good. And as far as use cases, Langchain can be applied to multiple use cases, including not limited to QA over structured data, such as database with SQL integration, with demonstration to Langchain's adaptability to both unstructured and structured data challenges. It is just streamlined what we can do with large language models. The importance of all these components is really key. And each of these components plays a pivotal role in facilitating the complex operations that modern natural language processing applications require. Agents and chains allow for dynamic operation and deep customization to meet specific needs. Tools enable us to have more effective communication. And as you can see here, we've got tons of different tools that are allowed, and different resources too. These cookbooks allow us to go in here and give us the formality and the path to code that we can use to start bringing in our large language models and permeating them to our use cases. We've got tons of different tools in here we can use for all kinds of things. Whether you need to use a large language model to infer some type of data, you can use large language models to get intent, sentiment analysis, similarity searching through your own data, through data that pre-exists. You can use it for detection, all kinds of different things. And some of the primary and main features of Langchain include offering components that are composable tools and integrations for working with large language models. These components are modular and can be used whether you are fully engaged with Langchain framework or not. The framework offers off-the-shelf chains and built assemblages components to accomplish higher level tasks. And Langchain pushes for simplification across the entire application lifecycle. From development, where developers can write and test applications using Langchain, through production, where they can monitor and deploy with confidence, and finally have some tools to harness the power of large language models and adapt these to real use cases. And like I said, we are going to see a demo of this in action and using Langchain tools, and I'll walk you through what we're actually doing. But let's go ahead and jump over to the papers real quick. Now, I'm not going to do a deep dive into these papers for brevity's sakes, but if you look at the slides that I did post, then you should be able to get the links in the footnotes and in the description. And basically, these papers, if you read them, it shows you how they've applied the reason and action steps with prompt engineering and using code to do iterative processes to make decisions based off of the prompt, and then decide whether or not they need to take another action based off of the first initial response that they've required. And it's pretty interesting. I've read through this paper a couple of times, and I've actually put some prompts together, and I figured out how to do this on my own, which is kind of complicated actually, and you got to really dive into the papers that they've cited here to do that. But it's a little bit of programming where you got to do some iterative stuff. But the reason and actioning is considered something that gives us an advantage of using LLMs, because right now all we could do is basically take in a large language model, send a prompt to it, and yeah, it can return us back all kinds of things. But this framework right here allows us to make that prompt think. And in retrospect, it says, okay, you take my prompt, and then based off that prompt, you decide whether you need to take more actions to find the correct information or use a specific tool to bring in information. And then once you get that response, analyze it again to make sure that it's correct. And basically, it gives it a thought process. And that's what's really cool about this. And this is in its infancy, and there's still a lot that can be explored with it. But I highly recommend reading this paper. And then the other one is the Retrieval Augmented Generation Knowledge Intensive NLP task. And this is all about using RAG and how we can leverage large language models with the embedding and vectorization of in-memory and out-of-memory tools to load data from all kinds of different sources. Like I keep referring back to like PDFs, CSV files, and text files, which sound very simple, but the components that we're using here is we are encoding this data so the large language models can understand it. We are vectorizing this data, and then we're using algorithms to do cosine or similarity searches, based off of this information. That way we can return back, the most similar response based off the prompt that we give it. We've got all kinds of different models. They've got RAG sequence models that they've tested, RAG token models, retriever models, which I find to be most lucrative. They've got a bunch, and I highly recommend reading this paper, both academically and unacademically. I would say if you are in the field of natural language processing or AI practitioner, then this is something you're probably going to want to read if you haven't done so already. But it really opens up your eyes to how we can take different paradigms in natural language processing to, harness different types of data. We can even use this for multiple data sources at once, which is really cool. So let's go ahead, other than that, and move on to the demo. So my runtime is disconnected. And let's go ahead and start this thing up. I might need to... No, it doesn't look like I need to do that, but let's go ahead and walk through this. All right, so I'm using OpenAI's 28.0 and these ones right here because literally last week OpenAI came out with GPT-4 Turbo. It kind of broke some stuff. I know all this stuff works, so I'm keeping it the same. I have API keys in here now, but for when I ship this out to you guys so you guys can check out the code, you guys are going to have to find your own API keys, and Langchain provides all of the instructions you need to do this. Now, I didn't really follow the example they have in the use cases for RAG because I've kind of built some of my own stuff, but we can go over this real quick. And basically what we've been talking about is QA over structured data, where we can talk to databases, documents, APIs, you name it. As long as it's got data on it, this gives us a framework to actually get that data and use it with the LLMs. And like I said here, we're loading documents, we're splitting that documents into chunks, we're vectorizing and embedding it, and then we're using it to do retrieval using different types of algorithms, whether it's cosine, similarity, or different similarity searches. But we're technically using similarity and vector searches to run over that data. So it's not contextual. It's nothing that matches words with words. It's all vectorized search data, which is really cool. And it's actually a lot faster. I've actually done some test benching at my job on a professional level with the vector search compared to searches like Elasticsearch, and this is way faster, and it's a lot more accurate, I find it to be. Unless you have the exact words you're looking for, which can pull back the response you want, then it's, then of course it's gonna know where to go and get it, and it can be fast. So it's gonna be faster than that. But if you got giant sets of data that you need to search through really fast, this is one of the most optimal ways that I found to do so. So I highly recommend going through here, reading these docs, going through here, and just checking out the confines of this. If the paper is a little too overwhelming for you, just bring it to this page right here, which I've also included in the footnotes of my presentation. You just go through here and it'll explain how it all works and how you use it with the code, which I know for me, I've been doing code for over 20 years. I've been a programmer and a developer, and I've been in AI for the past 8 years, so I've really like looking at code, and it makes a lot more sense to me. So I know a lot of you out there are probably a little bit more code minded in the sense of how things work. You can take things and see how they work with code, and it makes more sense to you. That's why I recommend you go take a look at these docs and walk through here. But it's really great stuff that we're going to use. So let's go ahead and get back over here and use it. So I usually keep this closed up, but you just have to run this, and then here's our bot. Now, the RAG tool that we're using, I'll walk through this with you real quick. We're going to import our knowledge base, which is just this CSV document, which is the Star Wars Q&A full data set that I've developed. I actually had GPT generate this for me because now it can actually generate spreadsheets for you. So you just tell it to generate a spreadsheet, and it will. We're using a template to ensure that it carries on the right type of persona and the right types of directives. And one thing that I found, especially talking to some of the natural language processing AI developers professionally, is how to structure these prompts. And we do it in a way where we're setting it up for a simulation and we're passing it directives. Some of people I do know of, I can't name drop academically here for this project, but I do know some people at OpenAI and for some other companies that work on AI tools specifically. And a lot of these are the way that they set their prompts up is what I'm doing here. And it's a way that they've defined how to set up their prompts and how to load them. Another thing is optimizing these prompts, removing stop words yourself, because the large language model is a big similarity search engine, basically. We've got all the data in the world, we vectorize it and embed it, and put it on there. And then it does these vector searches. So it doesn't know to remove stop words unless you tell it at this point. And a lot of stop words, it muddies, it puts interference into the query. See, even stop words like "and," like I have it a bunch of times in here. If we can be as explicit as possible with the less amount of stop words and less amount of interference within our queries, then it's going to be more accurate and always return more accurate results. And that's something you want to keep in mind when you are building prompt templates. It's something I picked up and learned the hard way, but when you're making production systems using this type of technology, you've got to climb a few hills before you learn a few things. Either way, what we're doing here, I'll explain the code, is we're pulling in the CSV file. I've got its own template, and then we've got another template. This prompt template's for the main agent. This is specifically for the tool. We're using Langchain functions, create CSV agent tool, and what this does is it gets the data, does the vector similarity search. It uses a zero-shot ReAct description, which is a one-shot search, the vector search basically, and it pulls back the most similar response based off of the ReAct framework that's coded into this. So this in itself is using its own large language model. It's using its own agent, and I've built a custom output parser here to process this. Now that's its own thing. Now the main agent is right here. So this agent, which you can see down here, is the main agent. His name is agent. And we're using what's called the chat conversational ReAct description, which gives us more context, which doesn't just do the initial search and actually puts a little bit more thought into going into the answers, and it's more conversational based, the way it's structured and the way the algorithm's written and the way the prompts are engineered. We're also passing in that big prompt template up here. So this is our main agent, and what this agent is able to do is it's able to sit back and, based off the prompt that we tell it down here, decide which one of these many tools we can use. Now I've got tools up here for the knowledge base, which we've seen up there, which when we call that agent here, what that's doing is it's triggering another large language model. It's triggering another agent that has the ability to do its own search separately. So we're chaining agents together to do a multi-agent functionality, and then we're taking this and we're outputting its information and its response, and then we're passing it back into the normal agent so that way we can get the initial response. Now we have tools for doing calculations because honestly, if you do some research into it, large language models can't do math very well. They fail at it a lot. And this is why Wolfman Alpha and different tools have been integrated into Langchain to allow us to do math calculations. And it's kind of important, especially if you're doing something with stocks or with blockchain or anything that takes numbers, financial stuff. You definitely want to use a calculator using an LLM. We've got the ability for online web search, which you got to get APIs for this, which I've shown you where to get them up there in the code. I've got just a basic chat model, which uses its own LLM. So in this all together, we're using 3 large language model calls. We're using 2 agents, and then we're using some integrated tools. And this is our bot, just to handle answering questions for, Star Wars information. What did you say? But we could use it for more robust use cases too. We could use it for, a different industry, trying to find different information for an industry. We can use it for medical, looking up medical knowledge, or being able to give people medical, advice or suggestions that didn't, violate any type of guidelines of privacy. It's pretty sufficient in what it does. As you can see here, I already ran it, and we can run it again if you want, so I can show you the process. But it enters what's called the agent executor, and since it already has the answer, it's going to return back to us, and I'll show you the reason why. Is because with all these tools and the ability to capture data in different means from these different sources, we're adding memory to this. It's able to remember what our last response was. So down here, if I run this, You see I've already got the AI message, my human message, and then I already knew what the answer was, so it didn't even have to go look for it. So if I put in here who made Star Wars, and we'll see. Can play with this a little bit. We'll ask it a question and see what happens. We'll see where it enters first. Final answer. So it's going right to its directives here. So let's look at the data here. Open that up and let's find a good question. I'll go ahead and put this at 100. Who is the Mandalorian's real name in the TV series The Mandalorian? So let's grab that question here because we want to get it from our data. I want to show you how RAG works. And we'll ask it a couple other questions too in this. So we'll ask it, who is the Mandalorian's real name in the TV series The Mandalorian? Plus, what is the current time and weather in Miami? Oh, let's go ahead and put in Boca Raton, Florida. See, now we're chaining different responses together. We're asking it for more verbose information. So let's see what happens here. And let's watch the process. So first it's doing an online web search, getting the time. Now it's going to our data set, which is this CSV file, and it's getting that information. And then it's doing another observation. This is ReAct in process. And then it gives us our final answer. Mandalorian's real name on the TV series The Mandalorian was Din Djarin. As for the current time, it is 7:13. It did not return the weather though. So I bet if I ask it, what about the weather? And I don't give it any context to what weather. Because of the memory that we've allocated to it, it knows exactly what it needs to get. And we'll see. There we go. And you can see how easy Langchain actually makes using large language models and how robust of information that we can pull out and use, and how how much further this gets us along with just sending a basic prompt and asking it a single question. This opens up a lot of new doors in relative to what these large language models can produce. So other than that, like I said, this code will be included. You guys, I wanted to go ahead and do one other thing real quick. Let me get past that really quick. Just one moment. Apologize, Professor. And I want to go to this conclusion page. And here I wanted to just drop these 4 tools and discuss these real quick. Now, we just seen that I've coded multiple agents together. So we're using 2 dynamic agents from the Langchain and from my own prompt engineering together to create cohesive and different responses for a retrieval system for Star Wars data. But AutoGen is a tool by Microsoft that has taken this a step further and allows us to simply define what we want our agents to do, and it has multiple agents. You can literally have 20 agents talking together in 15 minutes if you wanted to, and it's a really good tool. MemGPT is a tool that lets you manage the memory outside of the chain itself, so you can always have detailed memory of it, and you can store it and you can vectorize it and embed it as well. PrivateGPT is a tool that you can download that lets you use the RAG implementation on your desktop with your own documents. You simply go to PrivateGPT repo here, download it, set it up, very easy setup instructions, and then start feeding it your documents, your papers, and you can even code into it things that you need so you can build agents to return information back to you. And this gives you the privacy and anonymity of using large language models for your own personal needs. Then LM Studio, while everybody is using ChatGPT, LM Studio is something that is really super cool that allows you to basically have a platform to use all these different large language models, and it creates an API for you and it allows you to call them on your desktop. And I'll go ahead and show these to you real briefly. So the AutoGen site's here. This is an official Microsoft product, and I'm pretty sure this is what GPT is now using in their background with their new GPTs and their new releases of assistants and stuff like that they've had. So yeah, the GPT assistant agents, and you can use multiple agents together. It's really cool paradigm tool to use. I don't know if you guys have heard of this. MemGPT, I highly recommend reading this paper, but it unlocks a lot of functionality with LLMs, even using multiple LLMs to manage memory in between them. Very, very good tool, and this is something we use in production as well. Another thing is PrivateGPT. This is what I was talking about. You can download this, set it up, and you can have all the endpoints you want, the ability to chat to as many different large language models. This allows you to explore and try them and be able to integrate to your documents and to your data right on your desktop. And the other thing is LM Studio. This is free and it's totally cool, and I highly recommend everybody download it. Literally, you could use all the LLMs you want. There's tons of them out there. Llama 2, you can use the 70 billion Llama 2 if you like. Falcon is another good one. Minstrel is very, very good. I highly recommend that one. And there's just so many different large language models out there now. And most of these can actually compete with ChatGPT 4. Aside from the function calling, but you can fine-tune any of these models on your desktop simply by using this tool. So this is pretty much like VS Code for large language models, and it's a handy tool. I use it every day. So other than that, we'll go ahead and turn that. I appreciate your guys' time, and thank you for listening to my presentation. This is Sean Pritchard, CAP 6640, Florida Atlantic University. Thank you for listening to my presentation. Have a great day.